let's take a look at the concepts of graphing linear inequalities. So let's look at graphing linear inequalities. Okay? And when we talk about inequalities, we're talking about what? The four comparison symbols, right? Greater than, less than, greater than or equal to, and less than or equal to here. Okay, so we're talking about those four comparison symbols that we've seen in the past. All right. Now, before we get into that, let's consider this graph here. All right. Consider this graph right here. Let me make the graph. Suppose you're working for a for a company here, and let's say. Well, let's scratch that. Suppose I'm giving you a graph of average test scores here. All right. So, for example, let me draw. Let's say the average for all Math 50 classes, the test scores average follows this line right here. Okay. Okay. So this line is the average test scores. Okay. So sorry about that. All right. Let me give you some points on this line here. So, for example. This point here, the test score is for the first exam here. So exam 1, let's say the average was what? Was let's say 1. This point here is 1,72, for example. Okay. Let's say here's the second exam. So here's exam 2 here. 1. So exams. All right. These are scores. All right. Let's say for the second exam, the average, so this point here is 2, and let's say 75 was the average. Okay. And let's do one more here. Let's say this is exam 3 here. Okay. And let's say on the third exam, the average score was 80. All right. So let's suppose we have the following average. This line here represents the average test scores on the first exam, the second exam, and third exam. All right. So let's look at this problem here. So let me say suppose your scores are the following. All right. So for exam 1, your score was what? Let's say your score was 65, for example. Okay. Let's say for exam 2, your score was what? Let's make it 75 here. Let's say for exam 3, your score was 90. All right? So that means what? Basically, we have 3 data points here, right? So this is 165. That's your score here, right? This is 2, second exam, you scored 75. And third exam, 3. And you scored 90 on this exam. All right? So let's look at the first exam. So if you score 65 on the first exam, then are you above the line or are you below the line? Well, since the average on the first score was, was 72, then your first exam was 65. So you're down here. Okay, so you're over here. You're below the line. All right? Exam 2, you scored 75. Well, that means you're right at the average here of 75. That means you're on the line here, all right? And exam 3, are you above the line or below the line? Well, exam 3, the average was what, 80, but you scored 90, so therefore you were well above the line here, well above the average on the third exam, all right? So when it comes to graphing these inequalities, then when we graph them, the idea is to graph the line and determine whether the points that we want that will satisfy the inequality will be above the line, below the line, or on the line. Okay, so again, it depends on the inequality here. So let's talk about that. All right. So let's go ahead and clear out this screen here. Okay, so let's go and do that. All right. So suppose I give you this inequality. Let's go and graph the following. Let's graph y greater than or equal to x plus 1. Right? Real simple graph here. Right? Let's start with a simple inequality. Not too bad at all. All right. Now, before I even get into graphing it, let me ask you a few questions about this inequality, y greater than or equal to x plus 1. All right. So let me ask you this: Is the point 0, negative 1? Okay, actually, let me not use is. How about does, sorry about that, does this point, 0, -1, does this point satisfy the inequality? All right. So, so how can I check if this point, this ordered pair on the rectangular coordinate system will fit into this inequality? In other words, it will make that. Will this point make this inequality true? Well, how do I check that? Well, like I checked to see if this point is on the line or not, I just plug in, right? So similarly here, this time we have an equality, not an equation, right? But all you do is what? You just plug these numbers in for x and y to see if this inequality is true or false, all right? So does this point satisfy the inequality? Well, let's check that. So plug in 0 for x and -1 for what? Y. All right? So let's plug it in. So -1 for y, all right, greater than or equal to, there's my inequality here. X is what? 0 plus 1. So -1 greater than or equal to 1. Well, that's going to be false, as you can see, right? Because -1 is not greater than 1, and it's certainly not equal to 1. All right, so that's going to be false. So does this point satisfy the inequality? The answer is a resounding no. All right? How about another one? Okay? How about this point here? How about the point? How about the point 2, 2, 4? Let's say. Okay, question mark 2, 4. Does this point satisfy this inequality? Again, let's check that. Plug in 2 for x and 4 for y into this inequality here, all right? So 4 for y greater than or equal to 2 for x, right? 2 plus 1. So 4 greater than or equal to 3. Well, yeah, 4 is bigger than 3. It's not equal to 3, but it's bigger than 3, so therefore this is true. Okay, either you're greater than or you're equal to. In this case, we're not equal to, but we are greater than. So therefore this statement here is true. All right. So therefore, therefore, does this point satisfy this inequality? The answer is yes in this case. All right. Let's try another one. All right. Let's look at the point. Let's try the point -1, -1, 1, for example. Okay. Does this satisfy this inequality? Well, let's check again. All we do is plug in the check. Plug in -1 for x and 1 for what? For y. All right. So let's plug it in. Let's plug it in. So 1 for y, so 1 greater than or equal to x plus 1. So -1 for x plus 1. 1 greater than or equal to what? 0. Okay. Is that true? Well, 1 is bigger than 0. So yes, that's true. Okay. So the answer is yes. All right. Let's go ahead and test a couple of more points here. Let's test this point here. I'm running out of space on this whiteboard here, so I'll have to clear it out. But I'll put it back in, though, all right, in the next screen if need be. All right, let's test this point out. How about the point 3, let's say 3, 2. Right? Does this point satisfy this inequality? Again, once again, let's plug it into check. Okay, so 3 for x, 2 for y. So let's plug it in. So 2 greater than or equal to, so y greater than or equal to x plus 1. 3 plus 1. 2 greater than or equal to 4. Well, that's obviously what? False. 2 is less than 4, not bigger than 4. Okay? So the answer is no. This ordered pair does not satisfy this inequality. All right? So we have 2 points here that do not satisfy the inequality, and we also have 2 points that do satisfy the inequality. Let's go and test one more point here, if you will. Okay? Let's test one more point here. All right? Let's go ahead and test this point right here. How about the points? Let's make the point. How about 2? How about 2, 3? Okay? Does this point satisfy this inequality? Well, again, let's check that. Let's plug in. So I'm switching the 3 and 2 around, essentially, right? So 2 for x, 3 for y. Okay? So 3 greater than or equal to, and y greater than or equal to x plus 1. 2 plus 1. So 3 greater than or equal to 3. Well, in this case, 3 is equal to 3. It's not bigger than itself, but it is equal to itself. So this is true again. And so again, the answer is yes. All right? So as you can see here, we have what? We have 2 points I've tested that do not satisfy the inequality. I have 3 points I've tested that do satisfy this inequality up here. Okay, so let me go ahead and graph this line here. Think of this as y equal to x plus 1. Let me graph it on the next screen and test and show you where these points are relative to this line. whether it's above this line or below this line, for example. Okay, so let me go and do that. Let me go ahead and clear off the screen. Okay, let me write the inequality again. It was what? It was y greater than or equal to what? X plus 1 in the previous screen, all right? And we found 2 points that did not satisfy this inequality. So on the no category, it was what? It was 0, negative 1 didn't satisfy it, and 3, 2 did not satisfy this inequality. On the yes category, it was what? It was 2, 4, and it was negative 1, 1. Also, it was 2, 3 as well. So 2, 3. This is the yes pair. So these points, these order pairs did satisfy the the inequality there. All right. So let's go ahead and graph this line as I mentioned earlier, and see where these points are at relative to their positions on the line, whether they're on the line, above the line, or below the line. Correct? So let's go and do that. So let me go and graph this line. I'll graph using slope-intercept, so that's not hard at all. Okay, so not too bad at all. Okay, so let me graph that. Alright, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and 4. Okay, let's plot. So how do I graph this line? Well, the slope is what? 1, right? M invisible 1, right? The number next to x is 1 here, invisible 1. So 1. Let me treat that as 1 over 1. That means what? 1 up, excuse me, and 1 to the right. Okay, and the y-intercept of this line is also 0, 1. All right, so I'm starting off at 0, 1 here. Okay, that's the y-intercept, and I'm going to go 1 up, 1 to the right. So 1 up, 1 to the right. Okay, 1 up, 1 to the right. Okay, so let me connect them carefully. Again, easier if you have a ruler and graphing paper here. All right. Now, let's look at the no category, right? Let's look at the no category. Let me mark those with an X here on here. So are these points above the line or below the line in this particular problem here? Well, 0, negative 1. That's down here, right? So let me put an X here, 0, negative 1. Let me put an X right there. That's 0, negative 1. So that's in the no category, right? So X's represent points that any order pairs that do not satisfy this inequality, all right? So that's a no right here, 0, negative 1. How about 3, 2? So 1, 2, 3, 1, 2. There's 3, 2. Put X there. That's a no also, right? So again, so the points that do not satisfy this inequality are what? Are below the line. Can we observe that? All right? What are the points that do satisfy this inequality? Well, look at 2, 4. So 1, 2, 1, 2, 3, 4. Here's 2, 4. Let me put a little dot there, okay, for points that do satisfy. Okay, so 2, 4 is above the line. It's in the yes category. It satisfies this inequality. How about negative 1, 1? So here's negative 1, 1. Well, look, it's also above the line in the yes category. How about 2, 3? So 1, 2, 3. Well, this happens to be right on the line here, if you will, right? So, so we're saying what? We're saying that any point that's above the line or what? Or on the line will satisfy this inequality in this case. All right? So we're saying what? If any points up here will satisfy the inequality, yes. Any point that's down here will satisfy the inequality in this case? No, because you're below the line. All right? So how do I represent all the points up here that will satisfy this inequality? And everything above the line will satisfy. Everything on the line will also satisfy. So what do? Well, you just shade above the line. So just shade like this. Just draw these lines here to shade it. Okay? So what we're saying is, what this graph means is that anything above the line or on the line will make this inequality true. In other words, if I pick any point up here and I plug in for x and y, plug in its x-coordinate, plug in its y-coordinate, this inequality will be true. If I pick any point down here and I plug in its x-coordinate and its y-coordinate, this inequality will be what? False. Okay? So again, the idea is what? You graph the line. So first thing we do is we graph the line. Okay? Graph the line. And then what we do next is what? we determine if solutions are above or below the line. Okay, in other words, we determine if we shade above the line or shade below the line. In this case, we shade above the line. All right, let's try another one here. Let me put it off the screen here. Let's try another one. Suppose I want you to graph the following. Let's graph y equal to, let's say, oops, sorry, not equal to here, inequality, sorry about that, y, how about less than or equal to, that's much better, all right, 2/3 x, let's say, plus 1 here in this case, all right, let's go and graph that. So again, first thing we'll do is I'm going to graph this line here, so here's y, here's x, all right, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so let's again pretend this is what y equal to 2/3 x plus 1. Pretend it's equal instead of less than or equal to. All right. What's the slope again? Well, the slope is just 2/3. That means go 2 up, 3 to the right. And again, make sure we're used to graphing using the slope idea. All right. Y-intercept. Once again, it's going to be 0, 1 because b is 1. Okay, so not too bad. All right, so I'm starting off the y-intercept. There it is, 0, 1 again. This time I'm going to go 2 up, 1, 2, 3 to the right. 1, 2, 3. Excuse me, 3 to the right. And I get my line. Okay? All right, there's a sketch of that line. All right, now, do I shade above the line or below the line? Well, how can I find out? Well, let's test it then. Well, let's pick a nice point to test. Well, let's pick 0, 0. That's a good point to test, right? So let's test the order pair 0, 0. Okay, will this satisfy this inequality? Well, let's plug it in. Plug in 0 for x and 0 for y, essentially, right? So 0 less than or equal to 2/3 times 0 for x, right, plus 1. Well, 2/3 times 0 is 0, so 0 is less than or equal to 1, basically, right? That thing drops off. All right, is this true? Well, yes, it is, right? 0 is less than 1. So this is true. All right? So the origin, 0, 0, the point 0, 0, satisfies this inequality. It makes this inequality true, as you can see here. All right? That means what? And look at 0, 0, the origin. Is that above the line or is that below the line? Well, it's below the line clearly, right? So that means any point that's below the line will make this inequality true because of the less than, as you can see, as you might have guessed. Right? So how do I represent that? You just shade below the line. Okay, in this case, then the graph of this inequality looks like this. Okay, we graph the line and we shade below the line. All right. Now, so far I've given you the case of greater than or equal to in the previous example here, less than or equal to. All right. Let's look at the case where we don't have this equal sign here. All right. In that case, if we don't have the equal sign, then that is telling us that points on the line will not be part of the solution. So if there's no equal sign, you're going to graph the line differently. All right, so let's look at that example. Let me go and clear this out. Okay, let's go ahead and graph this inequality. Let's graph y greater than, okay, let's take the greater than case. Again, no equal sign here. Y greater than, let's make it negative 3/2 x plus 4, let's say. All right? So this time there's no equal sign. And no equal sign means that the points on this line will not satisfy this inequality. Okay? For example here, let's suppose I make a table to graph this line. Okay? Let me make a table here. Now we haven't done that in a while, but let's do that. Let's pick x, plug it in to get y. All right? Let's pick x to be 0, for example. Okay? So plug in 0 here, the whole thing drops off. I get what? Y to be what? 4. Okay? Let's pick x to be what? 2, because you want the 2 on the bottom to cancel out, right? So 2's cancel out. What's negative 3 plus 4? That's positive 1. Okay? So let's graph this line here. I want to show you the points. So these are points on this line. Okay, keep that in mind. All right? Okay, let's go and graph that. So 1, 2, 3, 4. 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay, 0, 4. So 0, 4 up here. Okay, our starting point. And you might have guessed that by looking at B here, right? And then go 3 down, 2 to the right. But I'm using a table here, 2, 1. So here's 2, 1. And you can see it too. 3 down, 1, 2, 3, 2 to the right. Okay, so again, I'm using a table to graph this time. Right? But I mentioned though that points, if there's no equal sign, points that are on the line. So this is the line. This is the diagonal I'm talking about right here. Right? Before I graph it though, let me mention this. Points on the line will not satisfy this inequality. For example, let's go ahead and test the point 2, 1. Okay, 2, 1. This is on this line, right, from this table here, right? So let's go ahead. That's this point right here. Okay, so let's plug in 2 for x, 1 for y. Okay, so 1 for y greater than negative 3 over 2 times 2 for x plus 4. Okay, 2's cancel out. So 1 greater than negative 3 plus 4. So 1 is greater than 1. Well, 1 is not greater than itself. So this is clearly false. Okay, so as you can see though, 2, 1 happens to be on this table, right? That means it happens to be on this line. That's this point here again, right? And if I'm asking you, does this point 2, 1, which is on the line, will it satisfy this inequality? The answer is what? No. This will not satisfy the inequality. So therefore, any point that's on the line, such as 0, 4, for example, is also not going to satisfy this inequality. So all points on the line, so again, if there's no equal sign, that means what? All points on the line will not satisfy this inequality. So how do I graph such a line? We don't graph it drawing it straight through like we're used to doing it. We're going to graph this then with a dashed line. So you graph it with a dashed line. A broken line, if you will. Okay. So the dashed line, the convention we use for saying that points on the line will not satisfy this inequality, is a broken line or a dashed line. All right. Now, where do I shade? Do I shade above the line, which is here, or do I shade below the line, which is down here? All right. Well, again, let's test this point here, 0, 0. Let's test the origin here, 0. Well, now again, I just picked 0, 0, but I could have tested what? I could have tested 0, 1. Just pick any point below, right? 0, 0 is easy because it's easy to plug in our heads, all right? So 0 for x, 0 for y. Okay, just easy point to test, all right? So y is 0. So 0 greater than negative 3 halves times 0 for x, right? Plus 4. Is that true or false? Well, 0 greater than, that drops off. I times 0, adding 0 there. 0 plus 4 is going to be what? 4. So therefore, is 0 bigger than 4? Well, the answer is no, it's not, right? So this is false. Okay, so this is going to be false right here. So therefore, this order pair 0, 0 does not satisfy the inequality right here. Okay, so again, this point down here, the origin 0, 0, I tested it, I plugged it in, it's false. So therefore, 0, 0 down here, which is below the line, will not satisfy this inequality. So that means what? Since points down here will not satisfy the inequality, that means what? Points up here will. So here, we're going to shade above the line. And you probably guessed that since we have greater than, we are going to shade above the line. Okay, in fact, that's what we have here. So again, the key idea for this problem is what? If there's no equal sign on inequality, you graph the line not as a straight through line, you use a broken line to graph it. Okay? So let's look at some of the guidelines that we have for you here. Okay? Let's look at some of the guidelines then. All right? So first, graph the mx, graph the y equal to mx plus b line. Again, but when you graph this line though, you either use a solid line if there's an equal sign on the inequality, or a broken line or dashed line if there's no equal sign on the inequality. So make sure you know how to graph this line, right? Either use a solid line or a broken line depending on the inequality. Okay. So let me say down here. Let me say use solid line. That means draw it straight through. If what? Use solid line for Well, for greater than or equal to, less than or equal to, again, there's an equal sign there, okay? And use dash line or broken line, if you will. Use a broken line or dash line like I did here if there's no equal sign. So use for what? For greater than or less than. Again, no equal sign on the inequality. Okay, so first we graph the line using this criteria. All right. Now we determine where to shade. Let me go ahead and continue the next screen since I ran out of space. Let me clear out this. Okay, so in terms of the shading here, so shade above or below the line. Okay, shade above or below the line. Now, what does that mean? Well, then, when do I shade above? When do I shade below? So let me say that for greater than or equal to, when you have that situation, you want to shade what? Above the line, as you might guess. Okay, and for the other case, less than or equal to, you want to shade what? Below the line. Okay, so again, depending on the inequality you get, do I use a broken line or a solid line, and do I shade above or below the line? Okay, so let's go and take a look at this one. Let's graph x plus 3y. X plus 3y is going to be what? It's going to be less than. Let's make it less than. Less than 6, for example. All right. Now this is not in mx plus b form, so you have to do some algebra to get this in mx plus b form. So let's do that. Let me right here. So x plus 3y less than 6. Okay. Again, you got to do the algebra here. Okay. So again, make sure we're sharp on algebra getting y by itself. So subtract x on both sides, and you've seen that before. We've seen that before, right? 3y is less than negative x plus 6, right? The x term first, okay? 6 minus x, negative x plus 6. Divide everything by 3. Divide both sides by 3. All right? So y is going to be what? Less than. Again, since I'm dividing by a positive number, do I switch the inequality? Remember, you have to do that if you divide multiply by a negative number. In this case, I'm not doing that. I'm dividing by a positive number. So I do not switch the inequality. Keep that in mind. Okay? But I'll give you an example of what we do later on. So that's, again, what's that though? Negative 1, a visible 1 here, right? So that's negative 1/3 x plus 2. Make sure we see that. Okay? So again, not too bad. Now I'm ready to graph this line. Now, it's less than, so that means what? And there's no equal sign here, right? So that means I'm going to use a dashed line here. And I'm also going to shade what? Shade below the line. Okay? So let's go ahead and graph this. So here's y. Here's x. So 1, 2, 3, 1, 2, 3, 2, 3. Okay, so start off at 0, 2 here. Again, we're not going to make sure we know how to graph this, right? So that means what? M is going to be negative 1/3, and the y-intercept here is going to be what? 0, 2. Okay, so again, this is from the last homework, right? So 0, 2 is our starting point. I'm going to go 1 down. Negative 1 means go 1 down, 3 to the right. Okay? So 1 down, 3 to the right. Rise over run. Okay, so let's make the dash line here, if you will. Okay, so dash line here. Okay, broken line here, right? Okay, so don't make a solid line. Use a broken line, dash line. So sorry about that. It looks like a straight through. It's not. It's broken line. Okay, so, and again, less than means you shade below the line. So, okay, so that's it. So not too bad at all. Okay, let's do another one. Let's go ahead and graph this one. Let's go ahead and graph the inequality. Let's make it. Let's see. Let's make it 4x minus y is going to be less than or equal to. Let's make it less than or equal to 2, for example. All right. Let's go ahead and graph this inequality. Again, once again, I need to get it in mx plus b form. So step 1, do the algebra to get y by itself on the left side, which is in mx plus b form. Then, all right. So 4x minus y less than or equal to 2. Subtract 4x to both sides. Make sure we see that on the algebra. Negative y less than or equal to negative 4x plus 2. How do I get rid of this negative sign of y? Well, it's a negative 1, a divisible 1 again, right? So divide both sides by negative 1. Divide everything by negative 1. All right? Not too bad. So that means we get y. Now, since I'm dividing by a negative number, what do? I switch the inequality, right? So from less than or equal to greater than or equal to. So we call that in section 3.3. So negative by negative is positive, so positive 4x minus 2. All right? So that's the mx plus b form for this inequality. All right? Let's go and graph it again. So m is what? M is 4, but that's what? 4 over what? 1. All right? So 4 up, 1 to the right. Okay, make sure we see that. The y-intercept here is going to be what? 0. Well, b is what? Negative 2, right? 0, negative 2 again. All right? So make sure we can recognize the slope and the y-intercept without too much trouble. Again, review your homework if necessary from the previous sections. All right? So let's go ahead and graph it now. So make my grid here, if you will. Okay, so there's the y-axis. Okay, there's the x-axis here. Okay, so let's see, 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 1, 2, 3. Okay, so I'll start off at the y-intercept 0, negative 2. So there it is, 0, negative 2. And go what? 4 up, 1 to the right. So 1, 2, 3, 4 up, 1 to the right. Okay? And am I going to use a dash line or solid line? Well, there's what? There's an equal sign on the inequality. If there's an equal sign, you use what? A solid line, because points on the line will also be solutions to this inequality. So I need to include these points. So therefore, I need to use a solid line. So so do not use a broken line here. Use a solidly drawn line. All right? Solid line. All right? Now, do I shade above the line, which is here, or below the line, which is here? Above or below? Well, look at this inequality right here. Okay, focus right here. Okay? Okay, don't look at this, because I had to switch it, right, when I divide by negative 1. So, greater than or equal to. So that means what? Above the line. So here's where all the points are above this line here. So therefore, this is the solution we're looking for. All right, let me go and clear this out here and do one more example for you. Or actually, let's do a couple more examples for you before we wrap it up. There's not going to be any questions to post on the discussion board for this particular section here. So no questions to post in Blackboard here at the end of the lecture. So let me go ahead and do a couple of more examples for you. Okay, let's try this one. Okay, let's go ahead and graph y less than, let's say, 3 here. All right? Okay, so again, it's less than, no equal sign here, right? That means we're going to use a dashed line or a broken line. So let's go ahead and graph this here. So here's y, and here's x. All right, so 1, 2, 3, 4. 1, 2, 3. 1, 2, 1, 2, 3. Okay, now, y less than 3. Well, look at this here. There's no x at all. So this is y and a number. Do you recall that? What kind of a line that is? If there's no x at all? Well, hopefully we can, that this is a horizontal line. Remember the horizontal line equation, y equal to k, right? So there's no x at all, and then we just draw a horizontal line at 3. Now, where do I go on 3? Well, you go to the y-axis on 3, on the y-axis. So you go 1, 2, 3, right there, okay? And then you make a horizontal line, but it's going to be what? A dashed line, okay? So it's going to be a dashed line, okay? Dash horizontal line. And do you shade above or below? Well, less than means you shade below them. Okay, not too bad, all right? How about this one? Let's go ahead and graph x greater than or equal to, 4 here, okay? Now that's going to be a vertical line, right? This will be a vertical line, if you recall. The vertical line equation we had was what? X equal to a number, right? There's no y at all. It's just x and a number. That's a vertical line. So how do I graph that? Let's look at how to graph that. So here's y. Here's x here. 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So we go to 4 on the x-axis, 1, 2, 3, 4, and we make a vertical line right there. Now, is it a solid line or a dashed line? Well, there's equal sign this time. So it's going to be a solidly drawn line, solid vertical line. Okay, no dashes, all right? Now, in the case of vertical line, I can't really shade above or below, right? Either I shade to the left or to the right, but it's greater than. What points have x coordinates bigger than 4? Well, points out here have x coordinates bigger than 4, right? So you're going to shade to the right of that. Okay, so in this case, we shade to the right for greater than. If it's less than, then we shade to the left for the case of vertical line. So again, y in a number, horizontal line. X in a number, vertical line. Keep that in mind when we review the concepts here. Okay, so again, no prompts to post on the discussion board. Just do the homework, and then we'll go over it in class. All right, so until next time. Bye-bye.